All right, next we've got number 32. So for this one, we want to find out what is f of x plus h first. So that's just going to be me plugging in an x plus h here for x. I'm going to go ahead and simplify that. So that'll just be 2x plus 2h plus 1, and then the 5 on top. All right, so now I'll do my difference quotient. So I got 5 over 2x plus 2h plus 1. And then minus, and then f of x is just the original function, all over x. I'm going to need to do a common denominator here, so multiply by 2x plus 2h plus 1. And then this side we'll multiply by 2x plus 1. All right, we're going to go ahead and distribute this as a negative 5. And so what I'm going to have is, and I need to distribute this as a positive 5, so it's going to give me 10x plus 5, and then negative 10x minus 10h minus 5. And then that's going to be all over our common denominator of 2x plus 1, 2x plus 2h plus 1, which I'm just going to leave in parentheses, and then that's all over h. Oh, I had it wrong there. It should be over h. Okay, now we'll combine like terms here, cancel some stuff out. And so all I have left is that negative 10h, so I'm going to multiply by 1 over h, which will cancel that out. And I get negative 10 over my common denominator there, 2x plus 1, 2x plus 2h plus 1. All right, next up here, they have the function. They want us to graph it. So this will just be our cubic graph, but I see that we do have a down 1 shift there. So I'm just going to make it kind of centered right there, and then it'll just look like our normal cubic function. So then we can go ahead and find the inverse here. So I'm going to say x equals y to the third minus 1. So x plus 1 equals y to the third. And then y equals the cube root of x plus 1. And so this is going to be our normal cube root graph, except it has a left 1 shift. And so cube root is just kind of the cubic on its side, but I'm going to put it center right there. So it's going to go like this and then go like that. And so one aspect of inverse functions is that they're always symmetrical about the line y equals x. So that's this line right here. And you can see that these are definitely symmetrical about that line. All right, next up we got some more domain here. So the numerator isn't really important for this. When I have a radical in the denominator, I always put the inside of the radical greater than 0. It's kind of a combination of our two rules. In the denominator cannot equal 0, but in the radical is greater than or equal to 0. So this is just greater than. So I'm going to go ahead and factor this. We got x minus 9, x plus 7. And then we do need test points here. I already kind of knew that because we have the quadratic inequality. So we're going to go negative 7 and 9. We've got to open circles here. And then you can test them out. So we get x equals negative 8. So that's a negative negative. And then x equals 0 is a negative positive. And then x equals 10 is a positive positive. So let's see, we're going to go that way and that way. So we get negative infinity to negative 7, 9 to infinity. All right, this one is asking for a slope-intercept form, so y equals mx plus b through that point and perpendicular to this line. And so I know for perpendicular, you always look at the slope here, and there m is negative 5 over 4, so my slope is going to be positive 4 over 5, the opposite reciprocal for perpendicular. I would just go ahead and set this up in a point slope form first, so y minus the y value equals m times x minus the x value. And then I would go ahead and distribute that in there since they want the mx plus b. And so that's going to be 8 over 5. And then I'm going to go ahead and add 6 on this side, and then I'm going to add a common denominator, 6 over here, so that'll be 30 over 5. And so that'll give me y equals 4 over 5x plus 22 over 5. All right, next up we're using the graph to evaluate these ones right here. So for this, for A, I would always do f of 3 first. You always start with the inside there. And so f of 3 is right here. It is 0. And then so we take that and we do g of 0. So g of 0 is up here, and that is 3. Next one, we would do f of 4 first. So f of 4 is 2. And then we plug that back in this case back into f. And so f of 2 is negative 2. Part C, they use the weird kind of a symbol here for the composite, but it really just means the same thing, g of f of 2. So we start off with f of 2, and that's right there at negative 2. And we take that and plug it back in to g, so then we do g of negative 2, which would be over here with a y value of 1. And then next up, same thing, but f of g of negative 4. So we do g of negative 4 first. Backtrack 1, 2, 3, 4, and that looks like it's 3. So then I'm going to do f of 3, and that'll be 0. All right, the next one here, I'm going to look at the piecewise function to see kind of what we're looking for here. So I see our top one is a quadratic, so that should be a parabola. And so I would kind of say, let's see, let's just start at negative 4. Okay, so I'm going to cross off this one. This one has like a constant. This one's linear there. So then I would say it's either A or D. Those both look like they might be quadratics. But I see this one is a square root function. And then I have a constant function. So that should be a horizontal line. So then I definitely think the answer is B just based on that. This obviously does not give you it's not a constant. That is actually more of a linear. And then this one is pretty clearly an absolute value. So those are kind of both wrong. All right, next up here we got a table. We can do a composite function there. So g of negative 1 would be this one, because we have our x value of negative 1, so that's negative 2. But then I have to plug that into the f function. So f of negative 2 would be 5. All right, next one here, when does f of x equal negative 2? That's really meaning when does y equal negative 2. So I like to kind of draw a line here, see where it hits. So it hits 2 spots. This is possible to get 2 x values here, especially if it's not a one-to-one function. So 2 answers is good. All right, next one here is asking for the average rate of change. So that's going to be y2 minus y1 over x2 minus x1. It's just the slope. They gave me my x values here, or they're really t values, but same idea. So I do need to plug those in to figure out my y values, or my h values in this case. So this is going to be negative 1 squared plus 7 times negative 1. So it's 1 minus 7, which is negative 6. And then for h of 1, I get 1 squared plus 7 times 1. So that's 1 plus 7, which is 8. So we'll just do y2 minus y1 over x2 minus x1. So that's going to be 14 over 2. So that'll be 7. All right, next up, number 41. So they want to know if this is a function. So I'd say with these repeated x values, I'm going to say that's a no. And that's what I'm looking for. And the x values are going to different y values. So if you kind of thought about this on the graph, negative 1 comma 4, negative 1 comma 5, these would fail the vertical line test. All right, next up here, we're determining which interval it's increasing. So it looks like this piece right here. We always describe this with the x interval. So I'm going to go negative 1 to 3. All right, next up we need to apply some transformations here. So we need to reflect this across the y-axis. That's going to be a negative inside. The x-axis is outside. Shrink vertically, what is going to be multiplying outside. And then a upward shift is going to be adding outside. I'm just going to apply all that to my cube root. So it's going to be a negative x on the inside for that y-axis reflection. And then a multiplying 1/2 outside. And then up 5 over 7 will be a plus. So I'll say y equals all that. All right, next up, we're going to do f of x over 2 here. So that just means plug in x over 2 for every x. And then we'll go ahead and simplify this by cross-canceling. And so that'll be, oops, that's not equals, that's minus. So it'll be 5x minus 8. This one, on the other hand, we take the whole function and divide it by 2. So that means we have to divide all the terms. So we get 5x minus 4. All right, next up we have our absolute value graph here. And they're asking us to write a formula for the new function of g of x. So it doesn't look like it's been shifted at all because the center is in the same spot. But instead of going up 1 over 1, it goes up 1, or sorry, over 1, up 1, 2, 3, 4, 5. And so, 5. So I would say that's a vertical stretch by 5. So I would put the 5 multiplying on the outside to make it a vertical stretch. All right, next up here, we need to write the equation for a line. It's got to be parallel to a line going through these points. So I want to find the slope of those 2 points. So I'm going to do 1 minus 3 over negative 1 minus 1. So that's negative 2 over negative 2, which is 1. And then I'm not going to use this anymore. I'm going to use this point and my point slope form, y minus 3 equals 1 times x minus 8. And then I would probably get that in mx plus b here. So y equals x minus 5. I see, though, that the answer is in standard form, so what we can do then is just move the x over to this side, and then usually they multiply that by negative 1, so they have their x value as positive. So those would also be correct. All right, next up here, they want us to write a piecewise for the first 4 brackets, which is all that's there. And then I'm going to go ahead and I'll let you guys check your answers on those. I'll just do the second part here. So Chris made $120,000. And then we're going to check all of these above the line deductions first. And so we always get to subtract those out. So we're going to do 120,000 minus, we got 7,000. And that's the only above the line. And then we'll have to decide if we do the standard deduction for 6,200 or if we do the itemized. So it looks like his itemized add up to 6,000. So I'd rather do the standard deduction of 6,200. So I'll do that in my calculator. And that's going to be a T of 106,800. So then I would plug that in to... let's see which piece. It would be this piece right there. And so how I would actually write this one would be 18193.75 plus 0.28, and then parentheses. And then it would be x minus 89,350, but since I know what x is in this case, I will put in 106,800. All right, so I'll type all that in the calculator and see what I get. All right, and so I get 23079.75. So that's his tax owed for Part B. However, we see that he paid $20,000 throughout the year, and so I subtract those amounts, and it looks like he did not pay enough, so he owes the difference, which would just be 3079.75 more. All right, next up, number 48, optimization again. So an auditorium has seats for 1,200 people, and they've been filled to capacity, and its tickets are currently $5. He estimates that for 50 cents increase, 100 few people will show up. So I always convert that 50 cents will be 100 less. I always convert that to $1, and so that's going to obviously change it by 200 because it's double the amount. So then I'll set up my revenue is just the cost of the tickets times the number of tickets, and then I can change the number of people that show up. It's 1,200 right now, but it says I'm going to lose 200 people if I increase the price, and so I'm going to put X first, and then I'm going to subtract the current price, which is 5. So if I raise it to $6, I am going to lose 200 people. So then I'm going to go ahead and just distribute. And then combine like terms, and then you can substitute it in there, and then you're going to maximize it. So you'll be looking for the vertex there. I'll let you guys finish that up. All right, 49, we got a piecewise function, so you just want to plug these into the correct piece. So f of -3 We'll go into this piece, and that is just 7. There's nowhere to plug it into. F of 2 will again go into there because that's right on the border, but this has the or equal to, so it's going to be 7 again. And then f of 3 will actually go into the other piece, 7 times 3 minus 3. And so it's going to be 21 minus 3, 18. All right, next up here, this one we're applying transformations, so shift it 3 to the left. So it would actually be x plus 3. It's the opposite of what you would think. Stretch vertically by a factor of 5, and then reflect across the x-axis is going to be a negative on the outside. All right, 51, we got domain, so we just have a radical here. It's really in the numerator because really the denominator here is 1. So that means it's greater than or equal to 0. So you're going to have to factor this, and the key on this one, again, is test points because it's a quadratic inequality. So I'll let you guys try that. All right, next up, number 52. So this one, the denominator cannot equal 0. So I would go ahead and factor this. I don't need test points, though, because it's not an inequality. So I just know that x cannot equal negative 2 or 2, but it can be everywhere else. So it's just negative infinity to negative 2, negative 2 to 2, and 2 to infinity. All right, next up here, we kind of have two pieces. We have a inside of a radical. It's going to be greater than or equal to 0, and then our denominator cannot equal 0. Now, it's actually not difference of perfect squares down here. I need to factor that. And so x cannot equal 0, x cannot equal 25. And then for this one, I would add the x over, which would say that it would actually say that 4 is greater than or equal to x, which I would interpret as x is less than or equal to 4. So we got 0, we got 4, we got 25. And I know I'm less than 4, so it's going to go that way. So I'm going to have negative infinity to 0, and then 0 to 4, and then it's going to stop right there. I don't need to include 25 because it's kind of not included either way. All right, 54, you got some transformations. I'll let you guys do that. 55, I'll do domain and range. So domain first. I see the arrow going left forever, so we are starting at negative infinity. I don't see any gaps until we get to 4. I see that there's not really a point at 4, so I'm going to skip over that. Remember, open circles are not really there, so I don't want to include them. And then it does go right forever, so then I got positive infinity. Now for the range, it goes down forever. Once again, you can see there, so we'll start at negative infinity. And then it looks like every y value is represented until we get to 1, and it stops just short of 1, so I'm going to use a parenthesis there. And then it does start back up again at 4, but once again, not included. And then it goes up to infinity after that. All right, 56, we got 1,200 feet of fencing. And then, so we know area is length times width here. And we know we can do 1,200 equals, and it looks like I have 3 W's and 2 L's. And then it asks me to write a function for area in terms of W, so that means I want to get rid of L. And if I want to get rid of L, that means I should isolate L on my substitution equation. So I'm going to subtract the 3W, and 1,200 minus 3W equals 2L. And then we'll divide everything by 2. So 600 minus 3 over 2W equals L. And so then I could say my area equals W times 600 minus 3 over 2W. You can distribute that in if you want. So negative 3 over 2W squared plus 600W. And then to maximize it, you're just going to find the vertex. I'll let you guys do that. I'll also let you guys do 57, just some more transformations.